Hi, today we want to consider quadratic trinomial as perfect square expressions. We want to know how we can use this concept to find unknown variables in quadratic expressions. Before we start, what is a perfect square number? A perfect square number is any number in which when you take square root of that, you get a whole number. So for example, the number 1 is a perfect square number because when you take square root of this, you get 1. The number 4 is a perfect square number because when you take square root of 4, you get 2. The number 9 is a perfect square number because when you take square root of 9, you get 3. The number 16 is a perfect square number because when you take square root of 16, you get what? Positive 4. Good. If that is the case, then let's transfer this to expressions. Now, what is a perfect square expression in terms of quadratic trinomial? Then we can conclude from the idea of perfect square number that perfect square expressions are expressions in which when you take square roots of them, you get a linear expression. Or better still, they are expressions which are of the form x plus or minus b all squared. Because what you are having here, when you try taking square root of that, then definitely this two will cancel this root sign. You are going to get a linear expression, which is x plus or minus b. So basically, that is a perfect square expression. So we can have a typical example of perfect square expressions like x plus 2 all squared, x plus 1 all squared, x minus 3 all squared. These are some examples of a perfect square expression. Okay, now how can we determine whether a quadratic expression is a perfect square expression? As it stands like this, you realize that if x plus 2 all squared is a perfect square expression, then we're trying to expand this. We are going to have x plus 2, x plus 2. And this is going to give us x plus 2 plus 2x plus 2. And this is going to give us x squared plus 2x plus 2x plus 4. And this will give us x squared plus 4x plus 4. So assuming you have been given this expression x squared plus 4x plus 4, how will you get to know that this expression is a perfect square expression? In general, if ax squared plus bx plus c is a perfect square expression, then this particular condition must hold. That is, b over 2a all squared supposed to be equal to c over a. This is a condition that governs a perfect square expression if you have it in the general form. So let's say we have x plus 3 all squared, which is a perfect square expression. Now, if we expand this in the general quadratic expression form, we are going to have x squared plus 6x plus 9. So we have this to be a perfect square expression. Now, this x squared plus 6x plus 9, we want to check if that basic condition for a perfect square expression hold. That is b over 2a all squared, supposed to be equal to c over a. From what we are having here, if you are to compare this particular quadratic expression to the general quadratic expression, which is ax squared plus bx plus c, what is our a? Our a is 1, our b is what? 6, and our c is 9. So testing, we are going to have our b, which is 6 over 2, our a is 1, all squared, supposed to be equal to our c, which is 9 over a, which is 1. Indeed, 6 divided by 2 times 1, which is going to give us 3. So we're going to have 3 squared is equal to 9. And indeed, we are going to have 9 to be equal to 9. So indeed, this is true. Okay, so we want to try and then use this particular concept to find some unknown variables. Okay. All right, so let's try this particular question. It says, find the value of k if x squared plus 5x plus k is a perfect square. Okay, now the question is saying that a certain value representing k is going to make the expression x squared plus 5x plus k to be a perfect square expression. So how do we find the value for k? The first thing we are going to do is, if ax squared plus bx plus c is a perfect square, then our b over 2a r squared is supposed to be equal to c over a. So with the expression x squared plus 5x plus k, if we want to compare this to the general quadratic expression, then we are going to have our a, which is the coefficient of x squared, to be equal to 1, our b, which is the coefficient of x, and that is equal to 5, and our c, which is the constant that is left, and our c here is going to be k. So with what we are having here, let's do the substitution. Then we are going to have our b, which is 5 over 2a. Now a is 1. R squared is supposed to be equal to k, that is c over a. So k over 1. So with what we are having here, let's do the simplification. We are going to have 5 over 2 r squared, and this is equal to k over 1 from the simplification here. All right. So that is going to give us 25 over 4. That's when we try simplifying this, 25 over 4, and that will be equal to k over 1. With this, if you want to find a value for k, then let's try and then do cross multiplication. So we are going to have the 25 multiplying the 1, and then the 4 multiplying the k. All right. So this is going to give us 25 times 1, which is going to give us 25, being equal to 4 times k, and that will give us 4k. We are solving for k, so we divide both sides by 4, divide here by 4, and that is going to give us 25 over 4, which is equal to k. So the value for k that will make the expression x squared plus 5x plus k to be a perfect square is k being equal to 25 over 4. Indeed, when the value for k is 25 over 4, the expression is going to be a perfect square expression. Let's consider this second example. Now the question is, find the positive value of p if x squared plus 2px plus 9 is a perfect square. Okay, so as usual, we know that for the general quadratic expression, if it indeed is a perfect square, then the condition that should hold will be what? B over 2a r squared will be equal to c over a. If that is the case, per the expression there, that is x squared plus 2px plus 9, we are going to compare this to the general quadratic expression, that is ax squared plus bx plus c. So with this, by comparing, we know that our a, which is the coefficient of x squared, is going to be 1. Our b, which is the coefficient of x, here is going to be 2p. And our c is going to be 9. If that is the case, then per the substitution, we are going to have what? We are going to have our b, which is 2p over 2a. Our a is what? 1. All squared will be equal to c over a. Sorry, and our c is what? 9. So we are going to have 9 over 1. Okay, with this 2 can cancel this 2. Okay, so we can have p over 1 all squared is equal to 9. And from what we are having here, p squared is equal to 9. So taking square root of both sides, because we want to find p, we equal to plus or minus 3, which implies that p will be equal to positive 3, at the same time negative 3. All right. So in that case, when p is equal to positive or negative 3, the expression x squared plus 2px plus 9 is going to be a perfect square. This brings us to the end of this video. Thank you for watching the video, but don't forget to subscribe.